Hello everyone, this is Prashanth, Institute of Aeronautical Engineering, Hyderabad. Let's continue with the last lecture. So here, now I am going to discuss about what is need for IoT system management. Need for IoT system management. So before that, what we had discussed in the last lecture. So that is the very important topics in IoT, SDN and network function virtualization. So these are the two things we discussed up to the last lecture: software defined networking and network function virtualization. Network, uh, network, network function virtualization. So the main difference between software defined networking and network function virtualization, along with what are the main characteristics of these two technologies, what is the advantages and disadvantages, what are the very popular versions of software defined networking, what are the main applications of software defined networking and network function virtualization. These are the things we discussed up to the last lecture. So simple software defined network, the difference between software defined networking and network function virtualization. So in software defined networking, just we have to maintain centralized servers, centralized control plane, for every data plan. So here we have data plane 1, for example data plane 2, data plane 3. So for these three, so we have to maintain centralized control system in software defined networking compared with natural traditional defined networking. In network function virtualization, so the main aim of network function virtualization is to boost the or enhance the operations of virtual systems. So these are the differences among between software defined networking and network function virtualization. So now I am going to about the need for IoT system management. So here, after difference between network, SDN and network function virtualization, the topic for another is need for IoT system management. So here the IoT system management or device management system or device management system management, device management. So now I'm going to discuss about system management applications. What are the main rules of IoT system management? Then apart from that, we have to discuss about device management main application. So here the need for IoT system management include different parameters like automating configuration. Automating configuration means compulsory every IoT device it can automatically detect the in network. It automatically it can just before connect it can configure. So after configuration is over, just it can connect, then process the data as per our requirement. So this is automatic configuration. The IoT system management can do this performance automatically based on our requirement. So here automating configuration. Next, monitoring operational and statistical data. So it can monitor the entire works involved in through the IoT device, then automatically process the data. After processing, it can analyze. That means it is in terms of statistical mode. So next, improve reliability. So based upon the practical conditions, it can improve the reliability of the system. Next, system wide configuration. So it is a not very simple configuration. So it acts as a very wideband, not narrow band, wideband configuration it maintain. Next to multiple system configuration. So it is not only single end with single device. It can connect to multiple devices with multiple networks or multiple configurations in here. So next to retrieving and reusing configuration. So one time is not enough. So again and again we can use and we can configure the devices. We can process the data. So this is about retrieving and reusing configuration. So it maintains different systems or different areas. So these are the types of IoT system management system. So here automatic configuration. So IoT system management capabilities can use automating the system configuration. So IoT system management capabilities can help the automating the system configuration. So automatically it can retrieve, automatically it can connect, automatically it configure the system or device. Next to monitoring operational and statistical data. We already know, so it can help monitoring the operational and statistical data of the system. This data can be used for diagnosis and prognosis service. So this is about second need for IoT system management. Next, to improve reliability. So a management system allows validating the system configurations. Validating the system configurations before they put into effect can help in improve the system reliability. So this is about the third one, improved reliability. Next, system wide configuration. So it is not end with narrow configuration. So it can maintain up to the certain level, that is in wideband configuration. So for IoT system that consisting of multiple devices, it's not end with single system or single server or single device or single configuration. So it can maintain multiple configuration or multiple systems or to the multiple devices or nodes. Ensuring system wide configuration can be critical for the correct functioning of the output. So this is about to system maintain wide configurations of the system. Next, to multiple system configurations here. For some systems, it may be desirable have multiple valid configuration which are applied at different times in a certain conditions. This is about the last button. Next, to retrieving and reuse configurations. So it can again and again we can use management system which have capability of retrieving configuration. So for example, any fault in fault or any error occurred in the system, that can again retrieve the information from the, even though the system is not working properly, but we are getting some information from the that device. So by using retrieving configuration mode. So here the devices can help reusing the retrieving, and after the completion of retrieving, we can reuse reuse the device. So reusing the configuration from for other devices on the same type of data. So these are the some main things of need for IoT system management: automatic configuration, monitoring operational and statistical data, improve reliability, system-wide configuration, multiple system configuration, retrieving and reuse configuration. So next, how some just we talk about some real time examples of IoT system device management. So here, how companies oversee IoT device management. So up to the last slide, we have discussed about what are the need for IoT system management. So now we go for device management. What is the specifications of device management system? Then how the companies oversee the IoT device management system. So the companies have been using IoT devices for a long time. So from agriculture also, from agriculture companies also monitoring two factors: weather conditions and crop conditions. To industrial companies tracking the output and safety within the manufacturing facilities. So companies and agriculture companies also can use IoT device based on the availability. So next, what are the basics in to oversee the IoT device management from any company? So here, these are the basics here. Provision devices using standard provisioning protocols. So here, the devices. So compulsory we have to connect to the device. After to maintain communication among all associated devices, compulsory we have to maintain some provisioning protocols also. So the all the things are comes under provision devices using standard provisioning protocol. Next, to take extra care when adding legacy technology to the network. So legacy means what? Compulsory we have to send information throughout the network by using throughout the network. So that is the legacy technology to the network. Next, to take failure into the account when planning device orchestration. So here, is there any failure in the system? So that again we can use by using some other methods. Next, to educate employees on cyber security good practices. Employees, just you can educate the employees based on our requirement. Next, to adapt to zero trust security system measures also we can use. Next, to choose low maintenance devices. So some devices, in those some devices we have to maintain, some devices the cost is too high, so that devices you can just ignore, just choose low maintenance devices as per our requirement. Next, to train and upskill employees on IoT device management. So train, just you can train to get the upskill for employees in IoT device management. So these are the some basics of IoT device management, some facts of for to see how companies are oversee IoT device management technique. So next one, in further briefly, provisioning devices, it is the first step in IoT management, provisioning devices. So what is the main role of provisioning devices? So the devices need to be activated or incorporated into a company's existing suite for IoT devices before they can be used. So doing that successfully for new devices takes several steps, starting with the IoT system identifying each new devices. Next, it has a do with discovery ways in which you can identify yourself to other parts of the system. So it is one of the scientist Mailer said. So you want to find simple ways in which you can connect things to standard and then go from there. So this is the main aim of IoT devices. The mailer said, that you want to find some find simple ways to in which you can connect the thing first. That means the connection is very important to gather the information or to send some information from one device to another device. So you can connect the things are devices. Things are in nothing but devices standard and from go from there. So this is the first thing, provisioning devices. Next one, orchestration needs to take failure into action, failure into account. So the mailer said, what mailer said, the second step of the IoT device is orchestration, so which makes sure connected devices are able to work together properly and can be controlled centrally. So it is not the every system having one control station as we discussed in the software defined networking also. So the same process here. So it can be controlled centrally. So system 1, system 2, system 3, system 4, system 5, like that we have different system. So the all the 6 systems are controlled by one central system, one central system. So this is the it controls centrally. The second sentence just it says like that. That means configuring more than the just IoT device. So with the help of this type of configuration, we can add more number of devices to the internet. So that is the one of the main role of IoT device management. It not just the devices; it's also the computers and the servers and various other elements that you how they make up our your system. So you need to find a way to bring all this together, making them work together as a single whole, he said. So these are the important words from the mailer said. So what is the truth? So it's not just the devices, it's also the computers and the servers and various other elements that you have make up your system. So work together is very important in order to build this type of activities. That is the end. Next one, securing IoT devices attackers. So in cyber security nowadays, the cyber attackers are increasing day by day, very huge number of huge number. So in order to prevent that type of attackers, so we have to maintain some firewall techniques or some security system. So here security is a big concern in IoT world. So in secure devices can easily let hackers penetrate systems and access sensitive information. And it's not just IT department that should be aware of the security concern, because of the numbers and varieties of access points. Employees also need to work with the other companies to keep the system protected. So this is about the securing IoT device against attackers. So Dell said, one of the scientists, the companies in the manufacturing industry could have thousands of connected devices. Within the factory, you have a last of different systems. He said there are more the computers and more servers, more and more microcontrollers. So based upon that, the word here is the broad aware of this issue. Is the broad investing this issue? It is putting money where it needs to be done. So this is about the first. The third one is securing IoT devices against attackers. Next, flexibility in management here. So it can be detecting to manage a large fleet of IoT devices, but the companies can set up, update, don't care as much. Carnera from Four Kites recommends that the companies think outside of the box when choosing the devices. So the more important thing that I think organizations need to understand, try to get as maintenance free as possible. So the conversation tend to be focused on technology, but the what many companies tend to forget these people of the equation. The they forgot the main, just they can follow the equation to do the other things. So there are some companies they forgot to follow the equation. So the Canada scientist said. So this is about IoT device should allow flexibility in management. So flexibility is nothing but the as per our convenience we can use the devices or we can process the data, we can analyze the data. Flexibility in any mode we have to provide the flexibility. So that is the thing in the through the IoT device. Next, IoT device management, what it is involved in the theory and why do you need it. Compulsory we have to know. So the device management refers to all the tools, capabilities and process necessary to support IoT solutions effectively at a scale point of time. Included are process are like are quickly and securely onboarding new devices, automatically identifying device issues, etc. So these are the 4 points need to know. Provisioning and authentication. Provisioning devices is different. Provisioning and authentication are different. Configuration and controlling, monitoring and diagnostics, software maintenance and updates. The first, provisioning and authentication here. So here, what is provisioning and what is authentication? Provisioning means just you initially it can verify. So it is the process of enrolling a device into the system. So before connect, just it can enroll, it can store all the details of the device before the connection. So that is the provisioning. Next, authentication. Authentication is just step that process of provisioning, whereby you can verify that only devices with the proper credential get enrolled. So this is the difference between what is provisioning and what is authentication. The provisioning is followed by authentication, or the process of provisioning is nothing but authentication. So this is the relative word provisioning and authentication. Next, configuration and control. So configuration means after authentication it can connect. After authentication it can connect the device. After connecting, just we can uh, pass the data. We can pass the data. Pass means compulsory. It can control whether the as per our requirement. It can control. So devices are imperfectly they are developed out in the field. So whether the attackers on a mobile asset like a car or a sensor, for remote monitoring like a refrigerator system. So after deploying, there may be a configurable device setting that you want to adjust to over the time, such as decreasing the frequency with which your attack report the positioning message to increase battery life. The ability to configure and control devices even after deployment, therefore critically ensuring functionality, improving performance and protecting from security threats. So these are the some points regarding configuration and control. So we can configure and control the entire system. That's it. Next one, monitoring and diagnostics here. So in addition to configure the certain device settings, that there may be also be unenforcedness. So here the ability to monitor and detect some Systems as a miss, such as higher than normal CPU utilization, is essential to proactively identifying and diagnostic potential bugs and issues. So we have to protect the bugs. So device management system can provide programs logs needed to make diagnostics systems also. So this is about monitoring and diagnostics involved. Next, software maintenance and update. So compulsory we have to maintain the software. Otherwise, there may be a get there may be get some drawbacks. So here compulsory we have to maintain software, and automatically the software will be updated. So if you identify a bug with your device, just you can example, if you identify a bug with your devices or security flow, you will need to be able to make updates to device software from afar. So the system automatically can update the system software with thousands or millions of devices. So the bugs are more compulsory. The system performance very slow, getting very slow. So that is the process. So getting physical access to each device to update them manually, just it's not practically problem. So the physical access is required. Your IoT solution may be doomed, or at least very brittle and precarious in the long run. So this is about the software maintenance and updates. So these are the things in IoT maintenance. So what it is IoT device, what is the main important role of device management to build IoT system, and why it is doing it. So these are the four important points: provisioning and authentication, configuration and control, monitoring and diagnostics, software maintenance and updates. So it just depends on the bugs. So the bugs are more compulsory. We need to update the system automatically. So then the system performance will improve based on that activity. So these are the four types of maintenance. So these are the references I referred for this lecture. Built.in, Internet of Things for IoT device management. Next to IoT for all.com. So it is for device management system. So these are the things IoT device management system and system management, device management, system management. So these are the things just we have discussed here: device management, IoT device management, and the system management. The need for IoT system management along with the device management and system management. So thank you.
Like, share, and subscribe. Hit the bell icon for more updates.